Mars isn't just a dusty red wasteland, it's a time capsule of human ambition. NASA's rovers have uncovered fragments of spacecraft scattered across its surface, sparking questions about our future in space exploration. Could these fragments hold hidden dangers? Or are they symbols of how far we've come? Highlight Ingenuity's historic flight and its significance as the first powered aircraft to fly on another planet. Mention its role in capturing aerial images of Perseverance's landing gear debris. Detail the fragments found by Perseverance, parachutes, heat shields, and backshells. Explain the importance of these pieces for NASA engineers. Every tear and dent is a clue for making future missions safer and more efficient. Use vivid imagery to describe the sight of a tattered parachute on Martian soil. Discuss Curiosity's earlier discoveries, including its own heat shield. Mention its decade-long mission and the challenges it has faced, like wheel damage. Emphasize its role in exploring Mount Sharp and studying Martian geology. Analyze the implications of leaving spacecraft debris on Mars. Are we unintentionally littering other planets, or are these fragments historic milestones? Introduce the philosophical perspective. These pieces represent humanity's relentless drive to explore, even at the cost of leaving a trail of our technological footprints. Focus on Ingenuity's achievements and its contribution to the mission. Envision a future where drones assist rovers in exploring Mars more efficiently. Discuss the significance of Martian soil and rock samples in uncovering ancient rivers and the potential for past microbial life. Tie back to the spacecraft fragments as part of this broader quest for understanding Mars history. Imagine the day humans set foot on Mars. These fragments will no longer be just debris, they'll be relics of our journey. Every fragment tells a story, not just of machines, but of humanity's unwavering spirit to reach for the stars. And one day, when we finally set foot on Mars, these relics will remind us of the bold steps that brought us there. The discoveries made by Mars rovers, including fragments of their own landing gear, are just the tip of the iceberg. These relics of human ingenuity symbolize a deeper connection to the Red Planet and the lessons we've learned along the way. As we push forward, each mission brings us closer to understanding not just Mars, but the broader cosmos and our place within it. One of the lesser discussed aspects of these missions is the durability of materials used in spacecraft. The remnants scattered across Mars serve as natural experiments, showing us how these materials fare under Martian conditions. Engineers carefully analyze the degradation of metals, fabrics, and polymers to understand how they respond to temperature fluctuations, high radiation, and the abrasive Martian dust. This research doesn't just benefit future Mars missions. It has broader implications for developing advanced materials for use in space habitats, interplanetary travel, and even structures on Earth. For instance, if a parachute fabric holds up better than expected, it could influence the design of deployable structures for other planets or even Earth-based projects in extreme environments. The growing concern of space junk is no longer limited to Earth's orbit. As we expand our exploration efforts to other planets, the question arises, how do we ensure that our curiosity doesn't lead to unintended consequences? Each fragment left behind on Mars represents a step forward in our journey, but also a potential hazard for future missions. Some experts suggest creating protocols for cleaning up after ourselves, even on other planets. These could include missions dedicated to collecting debris for recycling or study. On Earth, recycling metals is a routine practice, but on Mars, it could become a necessity. Future astronauts might use advanced 3D printers and recycling technologies to repurpose old spacecraft fragments into tools or construction materials for their habitats. Mars's surface is only part of the story. As Perseverance and Curiosity drill into the planet's crust, they are uncovering a world rich with secrets. Beneath the dusty, rocky exterior lies a record of Mars's ancient past, one that could rewrite our understanding of planetary evolution. Imagine a time billions of years ago when Mars had flowing rivers, vast lakes, and possibly even oceans. The planet's magnetic field, now long gone, would have shielded it from harsh solar winds, creating a more hospitable environment. By studying sediment layers, mineral deposits, and isotopic compositions, scientists are piecing together this ancient history, revealing a time when life might have found a foothold. The fragments left behind by our rovers evoke a sense of both achievement and introspection. They remind us of the fragility of human creations and the sheer vastness of the universe. Each piece tells a story of human determination, of the countless hours spent designing, building, and testing equipment to withstand the harsh realities of space. But they also raise questions about our responsibilities as explorers. Are we destined to leave a trail of debris across the cosmos, or can we learn to tread more lightly? As we prepare for human missions to Mars, these questions will become increasingly relevant. While the discoveries of spacecraft fragments are fascinating, they are part of a larger narrative, our dream of making Mars a second home. Establishing a sustainable human presence on the red planet will require innovations in energy, agriculture, and resource management. Future colonies might rely on solar power, harnessing Mars's abundant sunlight to generate electricity. Greenhouses could be built using lightweight, transparent materials capable of withstanding radiation while creating an Earth-like environment for growing food. And, as mentioned earlier, spacecraft debris could be repurposed, turning remnants of past missions into building blocks for new ones. Ingenuity, the plucky little helicopter, is paving the way for a new era of exploration. Its success has already inspired designs for more advanced aerial drones that could explore Mars with greater speed and precision. Imagine a fleet of drones working alongside rovers, mapping underground caves, analyzing the composition of cliff faces, and searching for signs of life in hard-to-reach places. The aerial perspective provided by drones could also play a critical role in identifying resources like water ice, which would be vital for sustaining human life on Mars. By pinpointing these resources, future missions can plan habitats and supply chains more efficiently. Looking ahead, the fragments of spacecraft left on Mars may one day become monuments to human ingenuity. Future generations of Martian settlers might preserve these sites, turning them into museums or historical landmarks that tell the story of humanity's first steps on another world. Imagine standing in a Mars colony, gazing at the battered heat shield of the Perseverance rover, now housed in a glass enclosure. The red soil beneath it and the stories it carries would serve as a powerful reminder of how far we've come, and how much farther we have to go. The journey to Mars is just the beginning. These missions are stepping stones to exploring other planets, moons, and beyond. As we refine our technology and learn from each mission, we are preparing for the challenges of exploring Europa's icy oceans, Titan's methane lakes, and even venturing beyond our solar system. Every rover that touches down, every drone that takes flight, and every fragment left behind adds to a legacy of exploration that will inspire generations to come. Mars is not just a destination, it's a proving ground for the human spirit, a place where we test our